Welcome to The Explainer. Today, we're diving into what is arguably one of the most incredible corporate turnarounds in modern history. We are tracking a 25-year hero's journey. We'll explore how a debt-ridden, nearly bankrupt semiconductor manufacturer totally transformed itself into the absolute, undeniable backbone of the global AI revolution. It's a wild story, full of contrarian leadership, agonizing engineering failures, and a visionary gamble that paid off right as the world changed overnight.
Okay, let's dive into this. The scale of where SK Hynix is today is just literally staggering. Heading into 2025, they are looking at a massive revenue surge to over 97 trillion Korean won. That's roughly 70 billion US dollars. But even more mind-blowing is their operating margin, which is projected at nearly 49%. In heavy manufacturing, that kind of profitability is practically an anomaly. They are quite literally dictating the pace of global AI. But to truly appreciate this towering success, we have to flash back. Because 25 years ago, this very foundation was crumbling, and this company was fighting a desperate, bitter battle just to survive.
Section 1. Crisis and Contrarian Becht.
The first chapter of this story starts with a massive existential crisis. Following the Asian financial crisis in the late 1990s, the South Korean government mandated this massive corporate restructuring, which became known as the Big Deal. Hyundai Electronics was forced to absorb LG Semicon. The result was this newly formed entity named Hynix, and right out of the gate, it was crushed under the weight of a $14 billion debt load. By 2001, thanks to the dot-com crash, memory prices actually plummeted below manufacturing costs. Hynix posted massive losses and essentially went into strict creditor control. They were effectively bankrupt, just barely surviving a brutal industry consolidation where a lot of other global players simply perished.
So for over a decade, Hynix just languished as this sort of ugly duckling under creditor management. Enter SK Group, a massive conglomerate traditionally focused on telecom and energy. In 2011, SK's chairman Chey Tae-won saw an opportunity where everyone else just saw a financial trap. He wanted to acquire Hynix. Internal SK executives fiercely opposed this. They were explicitly warning of a winner's curse and pointing out that there was zero synergy with their core businesses. But Chairman Chey forced the decision anyway. He had been personally studying the semiconductor industry, and his team submitted a $3 billion bid for a 21% stake, literally just 7 minutes before the deadline.
So, what drove this intense confidence? It actually stems from a really pivotal meeting Chairman Chey had with Morris Chang, the legendary founder of TSMC. Chang famously advised Chey that the secret to surviving this brutal industry wasn't just raw scale, it was partnership. He said, in a downturn, connect closer to your customers. In an upturn, do not rule over them. This brilliant piece of advice profoundly shifted Chairman Chey's corporate philosophy and really set the stage for everything that followed at SK Hynix.
Section 2. Commodity to mainstream.
With SK now officially in charge, they knew they needed a completely new strategy. They had to transition from making cheap commodities to engineering indispensable technology. Historically, the memory chip market was stuck in the commodity era. Companies just churned out standardized, interchangeable DRAM chips, competing purely on scale and price, which left them constantly victim to brutal boom and bust cycles. Chairman Chey wrote a direct mandate to change this. His vision was what he called the mainstream era. SK Hynix would no longer just make generic parts, they were going to build components so utterly critical and customized that the global IT ecosystem simply could not function without them. They needed to deeply co-develop architectures directly with their clients.
Section 3, HBM and bitter ordeals. And this brilliantly illustrates the path that vision led them down, straight into the grueling development of high-bandwidth memory, or HBM, a path that, quite frankly, was filled with bitter ordeals. The fundamental physics problem they were trying to solve was immense. Before HBM, the industry standard was GDDR5 graphics memory, which you can think of as a really rapid, fast-flowing river. It pushes data incredibly fast, but to push it faster requires exponentially more power, creating an impossible thermal bottleneck. HBM is entirely different. It's like the Amazon River. The individual flow is actually much slower, but the sheer volume is massively wider. By increasing the data lanes from just a few hundred to over 4,000, you drastically reduce power consumption while achieving absolutely unprecedented total bandwidth.
But to build this Amazon River, SK Hynix couldn't just lay chips flat on a board anymore. They had to build skyscrapers. When you look at the anatomy of an HBM stack, you have a foundational logic base die at the bottom, and multiple DRAM memory layers stacked vertically right on top of it. Connecting these layers are microscopic solder bridges called microbumps.
But the real magic here is the TSVs, or through silicon vias. These are thousands of microscopic tunnels drilled straight through the silicon dies themselves, creating these ultra-wide vertical data highways.
It was a beautiful theory, sure, but an absolute nightmare to manufacture in reality. During the development of their second-generation product, HBM2, their average yield flatlined at a dismal 50%. Think about that for a second. That means half of everything they manufactured had to be thrown right in the trash. The engineering was so relentlessly difficult that 3 different head designers had to be completely replaced over a painful 1.5-year period of constant delays.
The biggest culprit for all these failures was their packaging method, which was known as TCNCF. Think of it kind of like a smash burger problem. You had to stack and press one die at a time under 40 kilograms of intense pressure. If you're stacking 9 dies, you have to do this sequentially, over and over again. Just a single flawed connection or a microscopic cracked die ruined the entire module. And as if the engineering wasn't hard enough, the market collapsed right on top of them. Just as SK Hynix opened a brand new $400 million packaging plant, the 2018 crypto winter hit.
Bitcoin plunged 75%, dragging the rest of the tech market down with it. At that time, high-end GPUs were heavily used for crypto mining, and that happened to be the primary demand for HBM. So SK Hynix suddenly found themselves holding this incredibly difficult to manufacture, super expensive product, and basically, they had no buyers.
Section 4. MR-MUF Breakthrough Innovation.
So the crucial point is, faced with massive physical limitations and a crashed market, they didn't give up. Instead, they completely rewrote the rules of semiconductor packaging. They abandoned the industry-standard TCNFC process entirely. Instead, SK Hynix engineers innovated a radically new method called MR-MUF. Instead of that sequential, heavy pressing, MR-MUF is a parallel process. They stack all 8 or 12 dies at once, use mass reflow to melt all the thousands of microbumps simultaneously in just one pass, and then inject a fluid epoxy compound to fill all the gaps instantly.
When you compare the two, the difference is night and day. The legacy TCNCF method was slow. It applied immense physical stress and was super susceptible to die cracking. It simply couldn't scale efficiently past 4 layers. The breakthrough MR-MUF method, on the other hand, eliminated that heavy mechanical pressure hazard completely. It relied on uniform heat and liquid flow, slashing processing time, and enabling the perfect structural uniformity required for the massive 8-layer and 12-layer stacks that AI would eventually demand.
But making MR-MUF work in the real world wasn't easy. It carried a massive risk of creating void spaces or air bubbles between the microbumps. True to Chairman Chang's collaborative vision, echoing that early vital advice from Morris Chang, SK Hynix didn't try to solve this alone. They built a specialized micro-ecosystem, partnering deeply with Japanese engineering firms. They iterated over 50 times with a company called Hynix just to perfect the specific liquid epoxy and co-developed entirely new customized molding equipment with Towa. The result? They achieved a staggering 80% yield rate, securing a massive manufacturing advantage their competitors simply couldn't touch.
Section 5. Divergent Strategies with Samsung.
Let's move to NVIDIA and see how this builds a major crossroads, setting up a historic divergence with their primary rival, Samsung. Back in the late 2010s, the overall industry consensus was that AI would be localized, small models running on edge devices like your IoT gadgets and phones, requiring really low power. Samsung placed their big bet right here, developing HBM PIM, which actually integrated AI processing directly into the memory itself to save power. It was an elegant solution, but it required extensive software rewriting and really wasn't suited for massive central neural networks. SK Hynix, however, made a stubborn, highly contrarian bet. They stayed the course on massive, brute force centralized bandwidth. They pushed forward with HBM3, which was a highly expensive product with, at the time, still no obvious massive buyer.
Section 6. The Irreplaceable AI Ruler.
Now, what's really interesting about this slide is how the timeline played out. The AI explosion finally happened, entirely vindicating every painful, risky investment SK Hynix had made. Late 2022 was actually a trough for the industry. Memory prices were falling. But then on November 30th, 2022, ChatGPT was released. Suddenly, the entire tech world woke up and realized that large language models required immense, massive, centralized computing power. The world desperately needed high-performance memory to feed NVIDIA's GPUs. And because SK Hynix had stayed the course on HBM3 while others had pivoted away, they were virtually the only company on Earth capable of supplying it at scale. It was the absolute perfect storm. Today, it's genuinely awe-inspiring to see how they are leaning into this dominance. Their forward roadmap is just breathtaking, backed by massive capital commitments to build next-generation infrastructure, including a $4 billion advanced packaging plant right in the US and a $22 billion mega cluster in South Korea. They have completely transitioned from being a generic memory supplier to an irreplaceable core strategic partner for companies designing custom AI silicon.
It's truly a story of unwavering vision. By refusing to compromise on technological excellence, even pushing through financial crashes and devastating yield failures, SK Hynix didn't just survive the memory wars. They quite literally architected the very foundation of the AI era. Which leaves us with this incredible thought to ponder. How did a bankrupt entity meant for liquidation become the indispensable spine of the global AI revolution? It really makes you wonder, what other struggling ugly ducklings out there are quietly building our future right now? Think about it. Thanks for joining me for The Explainer today, and keep learning.